In previous class, we discussed exercise 1.1. In exercise 1.1, we see the LCMs and HCFs. We did some problems on LCMs and HCFs. Today, we have to see the exercise 1.2. So, in exercise 1.2, the first problem is prove that root 5 is irrational number. You have to prove that root 5 is irrational number. For this, now let us assume contrary that means before we going to root 5 is a irrational number, we have to know about what is an irrational number. Irrational number is nothing but the numbers which are not in the form of p by q. So what is the rational number? Rational number is nothing but the numbers which are in the form of p by q, where p and q are integers, q is not equal to 0. We discussed the definition of a rational number. So and we discussed the definition of irrational number also. So now before we prove to root 5 is a rational number, let us assume contrary that root 5 is a rational number. So whenever there is a rational number and there exists, then whenever it is a rational number, then there exists a and b are integers, where exist a and b are integers such that root 5 is equal to a by b. Root 5 is equal to a by b, but this means actually root 5, we have to prove that root 5 is a rational number, but we contrary take root 5 is a rational number, so that only I wrote a by b. That means it is in the form of p by q, where q is not equal to 0. That means b is not equal to 0. So now I am doing squaring on both sides. So now root 5 whole square is equal to a by b whole square. So this is square and root cancel. 5 is equal to a square by b square. 5b square is equal to a square. This is the equation number 1. So when 5b square is equal to a square, this means what? 5 divides a square, that is a square by 5. 5 divides a square, that is a square by 5. When 5 divides a square, it is automatically 5 divides a also. 5 divides a, that is a by 5. So now when it exists a by 5 for some integer c, that means a by 5 is nothing but, so there is a one value p by q. When we did the value of p by q, we got some answer. That means if I do 6 by 3, I got the answer, that is 2. So similarly 5 divides a is nothing but a divided by 5. Whenever we did a divided by 5, we got some answer, that is c. So for some integer c, so let 5 by a is equal to c. Yes, now we have to write it as 5 is equal to ac. 5 is equal to ac. Can you see once? See this is for some integer, there is a by 5 now. So let a by 5 is equal to c. Now this is a is equal to 5c. So here also squaring on both sides. If we do the squaring on both sides, a square is equal to 5c whole square. Now this is equal to a square is equal to 25c square. So in place of a square, from equation number 1, we have to write 5b square. 5b square is equal to 25c square. In place of a square, I have to write, since a square is equal to 5b square. This is from equation number 1. Now this 5 cancel in 25 how many times? 5 times. Now remaining value is b square is equal to 5c square. B square is equal to 5c square. So when b square is equal to 5c square, so it gives 5 divides b square. So that is what? B square by 5. It exists. So similarly 5 divides b or not? Yes, that is b by 5. Okay, so 5 divides b and 5 divides a. So therefore 5 is a common factor of a and b. 5 is a common factor of a and b. What we taken? We taken root 5 is equal to a by b. That means a and b are the co-primes, where a and b are co-primes. That means there is no common factor other than 1. So here we got 5 is a common factor of a and b. Therefore it is a contradiction that a and b are only a and b have only one common factor 1. It is a contradiction that a and b have only one common factor, that is 1. So therefore our assumption is wrong. What is our assumption actually? What is our assumption? We assumed that root 5 is a rational number. Our assumption, root 5 is a rational number. So our assumption is what? Wrong. That means root 5 is a rational number assumption is wrong. That means root 5 is a rational number is wrong. Therefore root 5 is hence root 5 is irrational number. So whenever our assumption is wrong, that is root 5 is a rational number, therefore hence root 5 is irrational number. Okay, this is first problem in exercise 1.2.